In section 14.4, we are introducing the idea of a logarithm, and it works something like this. So if we take something like 2 times 3 equals 6, well, we also know that that is the same statement as 2 equals 6 divided by 3, okay? Because multiplication and division are inverse operations, so we can rewrite this statement as this statement. Those two mean exactly the same thing. Well, if I have a statement like 3 to the power of 2 equals 9, I'm taking the first one from example 6 there, could be any numbers that are related like that. What's the inverse of that statement? Well, in one way we could say, well, the inverse of that statement is that 3 is the square root of 9. But what if we want to think about it this way? 2 times 3 equals 6. That's another way of saying 6 divided by 3 is 3 times what equals 6, okay? In this case, what if I want to think about it as 3 to the power of what? If I want to put the question mark here, okay, 3 to the power of what is 9. So you could think of it like this, something to the power of 2 equals 9. What's the something? Well, if we think about it like that, square root of 9 is what I want to do as the sort of inverse. If I'm wanting to do the inverse this way, 3 to the power of what equals 9, then that is what we're going to write as a logarithm, and it gets written like this: log to the base 3 of 9. So 3 to the power of something equals 9. What's the something? The answer is 2. Okay? So those two statements, this one here and this one here, are equivalent in the same way that these two statements are equivalent, because they're inverse operations. Log to the base 3 of 9 is the way that we say this, and that means 3 to the power of what equals 9. Log to the base 3 of 9 means what number do I raise 3 to the power of in order to get 9, okay? And we can think of it that way. We can think of it as, if I take log base 2 of 128, I can think of that as 2 to the power of what equals 128, and I get a 7. Or you can just think about it as this. I can think, well, if I've got a base there and an index there, the base over here turns into what we call the base of the logarithm, log to the base 2. The index goes over here, and the sort of answer bit, this number here, goes over here. So you can think of it as a sort of x to the power of y equals z is equivalent to log to the base x, the y goes over here and the z goes here. Okay, so you can think of this just as an algebraic relationship, as shuffle this here, shuffle that there, or you can think of it as 2 to the power of something equals 128. What's the something? Okay, and actually both of those ways of thinking about it are quite useful. So let's look at some examples then. Log base 3 of 81 equals 4. Well, if we just do the shuffling around, the base is 3, the index has ended up over this side, and the answer is 81. So I can just shuffle the things around. 3 to the power of 4 is 81. That is equivalent. That's an equivalent statement. Or I can think of it as 3 to the power of what equals 81, or 3 to the power of 4 equals 81. Okay. So when we get into things like this, log, and I'm looking at example 8, part B now, log base 4 of 0.25. Well, 0.25 is a quarter, isn't it? So 4 to the power of what equals a quarter? Well, that must be minus 1, right? 4 to the power of what equals a quarter, that must be minus 1. So if you're thinking of it as the base to the power of what equals this number here, hopefully that's sort of obvious. If you're thinking about it the other way, you think, well, that is 4 to the power of something equals 0.25, because we're saying log base 4 of 0.25, we want to know what it is, so that is a something. So this thing to the power of this thing equals this thing, and we can write it like this. And now we're thinking, well, that is 4 to the power of something equals a quarter, so the something must have been minus 1. Okay? Let's have a look at one more. So log to the base a of a to the power of 5. If you're thinking about this, the way of the method of a to the power of what equals a to the power of 5, well, that's going to be a 5, isn't it? So that one's just sort of ramming home this idea that they are inverse operations. Okay, so if I had x times 3 divided by 3, you know that's always an x. If I get a to the power of 5, and then I take log base a of that, I get the 5 back. Okay, so if the 5 is in the exponent, and then I take logs, I get back to the number that I started with. So that's really everything they're asking us to do. Oh, sorry, there is an extra little bit, which is there is a log button on your calculator. Now, on your calculator, there will be 3 possible log buttons. I'm not going to get my calculator and show you. Everyone's got different calculators, and they change models every few years anyway. So you look for these buttons. You've got a button that just says log on it. You've got a button that says ln on it. Now, just a log on its own means log base 10. Okay? Now, that's a helpful thing to have, because if I've got something like log base 10 of 543, well, I know 10 to the power of 1 is 10. 10 to the power of 2 is 100. 10 to the power of 3 is 1,000. 10 to the power of 4 is 10,000, and so on. Okay? So 10 to the power of what is 543? Well, I know that number is bigger than 2, because 10 to the power of 2 is 100, 10 to the power of 3 is 1,000. So log base 10 of 543 must be bigger than 2 and less than 3. Okay? So logs of 3-digit numbers are 2 point something. Log to the base 10 of, I don't know, 74198. Well, that is a 1, 2, 3, 4, 5-digit number. So it's bigger than 10 to the power of 4, and it's smaller than 10 to the power of 5. So this is between 10,000 and 100,000. Sorry. It's between 10,000 and 100,000. So log base 10 of that is between 4 and 5. Okay? So it's, given that we sort of tend to think of things in that way anyway, if you think of large numbers, you think, are they millions, tens of millions, hundreds of millions, or billions? This is this just gives you the integer part of the log base 10 of a number will give you how many digits are in it. Okay, so that's a sort of helpful one. The other one that's helpful is natural log, which is ln stands for natural log, which means log to the base e, and we met the number e earlier on in this chapter. Now that is the one that we're going to use almost all the time, but we come back to it in the last part of this chapter, I think, the last section. So I'm going to ignore it for the moment, but we're just mentioning it that there is a natural log button on your calculator, and actually, once we've got used to logs and we've played with them a little bit in this chapter, we'll, for the rest of the course, in the pure section, that's the natural log, that is the log that we will use. And the other button that might be on your, well, should be on your calculator, is log to the base something of something. So you can put any base you want in there. So example 9 is just asking you to use your calculator to calculate things like log to the base 3 of 40. Well, just put a 3 in there and put a 40 in there. You should be aware, though, that some of these, not always, but you can estimate how big it should be. So 3, if we go through the 3s, 3 to the power of 1 is 3, to the power of 2 is 9, to the power of 3 is 27, to the power of 4 is 81. So the answer should be between 3 and 4. Okay, 3 to the power of something is 40, that's something between 3 and 4. And that's helpful because every time you want to type something in your calculator, you want to try and estimate what the answer is going to be, if at all possible. So that is section 14.1 all done.